second subtopic, which is on radioactivity. So in this subtopic, you have to be able to explain what is alpha, beta plus, beta minus, and gamma decays. State what is decay law and use this equation here. Define and determine activity, which is A, and as well as the decay constant. And use these two equations as well as define and use half-life punya equation. Right, so radioactive decay. So this decay, radioactive decay, is defined as the phenomenon in which an unstable nucleus disintegrates. Okay, they disintegrates to acquire a much more stable nucleus lah. Okay, so why do they disintegrate? Because they want to have a much more stable nucleus. Okay, and without absorbing any external energy lah. Okay, so this disintegration commonly involves the emission of an alpha particle ataupun a beta particle and a gamma ray. Okay, so it also releases an energy which we call as Q, known as disintegration energy. Okay, so radioactive decay is a spontaneous reaction, so it is unplanned and cannot be predicted. Okay, so it is very independent of any physical conditions. Okay, it does not depend on pressure or temperature. That's why it is called spontaneous. Okay, and then this reaction is random because the probability of a nucleus decaying at a given instant is the same for all the nuclei in the sample. Okay, random reaction and spontaneous. Okay, and then alright, so let's go on to what is alpha particle, beta particle. So alpha particle is a particle that consists of 2 protons and 2 neutrons. Okay, so it consists of 2 protons and 2 neutrons. Okay, so it is identical to a helium nucleus and its symbol is similar to the helium element lah. Okay, so it is positively charged and its value is positive 2e with a mass of this. Okay, and then when a nucleus undergoes an alpha decay, it loses 4 nucleons, 2 of which are protons. Thus, the reaction can be represented by this equation here. Okay, so this is the alpha decay punya reaction. And then these are the examples of alpha decay. If you look at this, we can see that they lost 2 proton. So 84 minus 2 tinggal 82. Lepas tu yang the atomic number loses 4. Okay, so minus 4 dia tinggal 214 lah. Alright. Okay. Lepas tu beta particle pula, they are electrons or positrons. Okay, so it is sometimes called beta minus and beta plus particles. So it is represented this way lah. So beta minus is this one here, ataupun this one is the positron, which is the positive. Lepas tu what else? So it's written just there. These are the examples of beta minus decay. So if you look at this, why is this so confusing? I think this one should be lower. So okay, I edit that later. But if you look at this, for a decay into beta minus, so 90 ni dia, it will before why am I so confused? Okay, wait. Right, so untuk beta minus decay, instead of losing a proton, dia akan gain +1 here. Okay, ini untuk beta minus. Untuk beta plus decay pula, a positron is emitted lah. So this time the charge of the parent nucleus decreases by 1. Okay, so if you look at this, di sini sekarang 1. Lepas tu dia minus dengan 1, so tinggal 0. Okay, Vini di sini, it is a known as neutrino. It is an uncharged particle with a negligible mass. Okay, yeah, this one is for beta minus, this one is for beta plus decay. I'll edit this, which I'm confusing kan? Okay. Gamma ray pula. Gamma ray are high energy photons. These are high energy photons. For example, electromagnetic radiation. Okay, so emission of gamma ray does not change the parent nucleus into a different nuclide, since neither the charge nor the Declan number is changed. Okay, so there's no changes untuk gamma ray. Okay, untuk gamma ray, photon is emitted when a nucleus is in an excited state. Okay, so they are in an excited state, which makes a transition to a ground state. Okay, so from excited state, they be ground state. So these are the examples of gamma ray decay, gamma decay. So if you look at this, the cepat. Tidak pula maksud yang ini. Let me just double check. Sorry everybody, just skip this part. Silaju sejalar. Oh, actually beta minus tadi I forgot to add something. Okay, so untuk gamma decay, apa dia tidak explain? Okay, it's okay. So untuk gamma decay, dia akan ada addition of gamma ray. Okay, but then yang ini, it is similar to the alpha ray punya. So the proton number will be subtracted by 2. This one will be subtracted by 4. Okay, tapi don't forget to add gamma ray. Okay, so the gamma ray is uncharged. It is neutral and has zero mass. The difference between gamma rays and X-rays only in the manner of which they are produced. So gamma ray are a result of a nuclear processes, whereas X-ray originate outside the nucleus. Okay, alright, so these are the comparison of the properties between alpha, beta, and gamma ray. So the charge untuk alpha, they are positive 2e, beta they ada negative and positive, and then gamma is uncharged. Deflection by electric and magnetic field, only alpha and beta is affected. Gamma no. Ionization power, gamma is the weakest, whereas alpha is the strongest. Penetration power pula, of course gamma is the strongest one, and then all three of them have the ability to affect a photographic plate and also produce fluorescence untuk all three of this. Okay, so this figure is showing the deflection of alpha, beta, and gamma in electric and magnetic field. Okay, so remember the gamma ray is uncharged, so it won't be affected by any of this plate. That's why it goes straight line. Okay, and then untuk alpha pula, it is a positive charge, so it will be attracted to the negative terminal. Same as the beta particle, it is a negative charge, so if it's a negative charge, it would be attracted to the positive terminal. Okay, decay constant, the symbol is lambda. Okay, so there's a law in this section. So the law is on law of refractive decay. So the law states that for a radioactive source, the decay rate is directly proportional to the number of radioactive nuclei remaining in the source. Okay, so mathematically it can be written as shown here, where the lambda is the decay constant and the negative is just telling us that the number of remaining nuclei decreases with time. Okay, so rearranging the equation above, we get that the decay constant is just this. Okay, so the decay constant is then defined as the probability that a radioactive nucleus will decay in 1 second. So the unit is per second. So the decay constant is a characteristic of the radioactive nuclei. So if we rearrange the decay constant equation, we get this. Okay, so if we integrate this in terms of, this one is in terms of n and this one in terms of time, we then get the equation here. Okay, so this equation is the exponential law of radioactive decay. Okay, so this equation can be drawn graphically, which is the one shown here. So the graph n is this one is the number of remaining radioactive nuclei in a sample against time. Okay, so from the graph here, which is known as the decay curve, the life of any radioactive nuclide is at an infinity. Okay, so in order for us to talk about the life of the radioactive nuclide, we are gonna refer it as the half-life. Okay, so half-life siya kita akan tahu. Right, half-life ni pula apa? Half-life is defined as the time taken for a sample to disintegrate to half of the initial number of nuclei. Okay, so we get the equation just now and the definition of half-life, which is T equal to the half of the period, and we get N equal to the initial number of nuclei divided by 2 lah. So we get this one. And then we are left with just the half-life punya equation, which is this one here. Okay, so the half-life of any given radioactive nuclide will be constant. It does not depend on the number of remaining nuclei. And the units of half-life can be second, minute, hour, day, ataupun year. Okay, the unit depends on the unit of decay constant. Kalau the decay constant is given in hour, then your half-life will also be in hour. Okay, so these are some of the half-life of several isotopes. For uranium, the half-life is 4.5 times 10 to the power of 9 years. Okay, gitu-gitu aja lah. And then, okay, that is on half-life. Let's look at the activity of radioactive sample. So activity of radioactive sample is defined as the decay rate of a radioactive sample. The unit is number of decays per second. Number of decays per second. Other units can be curie ataupun becquerel, which is the SI unit juga lah. Okay, so the unit conversion, 1 curie is 3.7 times 10 to the power of 10 decays per second. 1 becquerel is 1 decay per second. So the relationship between activity of radioactive sample and time is shown here. Okay, so this is the this is equation where you calculate the activity of a radioactive sample lah. All right. Yep, that is on our subtopic number 2, which is on radioactivity. If you are confused on this, we just need to look through the examples so that you can understand more lah. Right?